You know, we have no idea how planets form or evolve, but sometimes they leave us hints. And in the case of Uranus, there is something so unusual about it that scientists think it must have been caused by an ancient catastrophe. What might that be? Uranus is the sideways planet. All the planets in the solar system rotate on their axes with slight tilts. Mercury is at 2 degrees, Venus at 76 degrees, Earth at 23 degrees, Mars at 25 degrees, Jupiter at 3 degrees, Neptune at 28 degrees. Uranus is at a whopping 98 degrees. It rotates almost perfectly on its side. It's the only planet in the solar system that rotates in the opposite direction to the others. Everything about Uranus is weird. Scientists have many theories to explain this extreme axial tilt. Perhaps it was a very wide binary planet that merged with another object, or maybe it was a very young planet that got too close to Jupiter and was nudged out of its orbit. But the most popular theory is the ancient collision theory. The idea is that very early in its life, Uranus got hit by something really big. It knocked the planet completely over onto its side. Now, it's important to note that none of these theories have any evidence to support them. Scientists have only been able to rule out some. For example, the binary merger theory falls apart when we look at Uranus's rings. If Uranus used to be two separate bodies, we would expect to see evidence of that in the rings. So right now, all of these ideas are just guesses. But the ancient collision theory is the one that makes the most sense. For starters, if we look at the other planets, all of them are more or less aligned along the Sun. Well, except for the Earth, but that's because it's slightly misaligned. All the planets formed from the same disk of spinning gas and gravity cause them to flatten into spheres. They're oblate spheroids. The Earth has a slight bulge at the equator because of its rotation. That's why we call it a fast rotator. Uranus has no bulge at all. It looks more like a trilobite than a ball. A trilobite is a fossil of a type of extinct marine animal. If Uranus was just spinning normally, it should look like the Earth, even if it was knocked over. Something more than a simple nudge was needed to make Uranus look like this. Okay, so we know that it was probably a giant impact. But what about Uranus's retrograde rotation? Why is it spinning backwards? Well, we can answer that by looking at the orbits of Saturn's moons. These objects were not formed from a spinning disk of gas. They're a population of asteroids that were captured by Saturn. The smaller ones are probably fragments of larger bodies that broke apart before getting caught by Saturn. Many of Saturn's irregular moons rotate in the opposite direction to the planet. This suggests that they were created from something that spun in the opposite direction, like a planet. Scientists think that Uranus used to spin faster than it does today, and that's why so many of Saturn's moons have this backwards rotation. This also explains why the crash didn't destroy Uranus completely. The thing that hit it had a similar mass to Uranus itself. If they were both spinning in the same direction, the impact would have changed the rotation speed and direction of the planet. Uranus would now be spinning like Saturn. Because they were spinning in opposite directions, the impact only changed Uranus's rotation speed by a small amount. But what could have caused such a massive impact? Could something so big exist outside the orbit of Uranus? Well, it turns out that the Kuiper belt might have contained many more objects than it does now. Most of the objects in the Kuiper belt are second-generation objects. They formed from the material left over after the planets formed. There may have been many more first-generation objects, things that formed at the same time as the planets did. And one of these could have been large enough to knock Uranus on its side. But if this happened, where did the object go? Well, the thing that hit Uranus might not have been destroyed. Some scientists speculate that it actually still exists today as a dwarf planet in the outer solar system. There are a few candidates, but the leading one is Quasar. You know, I always get asked how I come up with names for these videos. Well, I usually just take the name of the scientific paper I am covering and make it sound more exciting. But in this case, I wanted to use a name from the outer solar system. So I looked up a list of dwarf planet candidates and found this one called Quasar. It's pronounced Kwaoar. It comes from the North American English word qua, which means friend. It's appropriate because the ancient collision theory says that Uranus and this hypothetical dwarf planet were once friends before their fateful encounter. But let's get back to the ancient collision theory. In this scenario, Quaoar never got destroyed. It continues to exist in the outer solar system as a dwarf planet. Other scientists disagree. They say that if the impact that knocked Uranus on its side also kicked the other object out of the solar system, then the present-day Kuiper belt would have a lot more objects in it. It would be much denser. So there is still debate about whether the ancient collision was a solo event, or if Uranus had more than one large visitor. Some scientists even speculate that the current axis of Uranus is the result of several impacts. It started out spinning like most planets, with the axis almost perpendicular to the Sun. Then it got hit so many times that the impacts averaged out to a rotation on its side. This might explain why the orbit of Uranus is so misaligned, 6 degrees relative to the Sun. Several impacts would also explain why Uranus has so many rings. If a planet gets hit by many different objects, the combined effect of all those impacts will deform it into an oblate spheroid, and Uranus is even more deformed than the Earth. It's as possible that the ancient collisions knocked it out of its orbit and into a region where it was showered with smaller objects. As these smaller objects rained down on Uranus, they carved out vast canyons and deposited material into orbit around the planet. Today, that material has coalesced into Uranus's famous rings. So that's 3 scenarios for the ancient collision. One big object, many objects, or many objects plus a giant gravitational nudge from Jupiter. We don't know which one is correct. Maybe the truth lies somewhere in between. Did Uranus's axis really get straightened out by several impacts? How did all those impacts align themselves almost perfectly with the Sun? What was the origin of the objects that bombarded Uranus after it was knocked onto its side? One thing's for sure, the ancient collision theory, whatever version of it is correct, has some major implications. If we want to understand how planets form, we need to figure out how they evolve after they form. Some planets remain relatively static, like Mercury and Venus. Others change dramatically, like Uranus. If we can better understand how Uranus evolved, it could tell us a lot about the history of our own planet. In fact, Earth could have had a similar history. When Mars and Earth formed, they were much closer together. They migrated inward and outward many times. It's possible that at some point Earth was knocked on its side, just like Uranus. If that happened, we would expect to find evidence of it in the Moon. The Moon formed from material thrown off by a giant impact on the early Earth. If the Earth was knocked on its side, the angle of that impact would have been recorded in the Moon. And it turns out that the Moon's orbit is mildly inclined relative to the Earth's orbital plane, about 5 degrees. But the angle of the orbit doesn't match the angle of Earth's rotation. So the giant impact that formed the Moon did not knock Earth on its side. It's possible that Earth experienced many impacts in its early life, but we need to find evidence of one that knocked it on its side. The search continues. I've covered some interesting research on this topic in a previous video. Check it out here. Thanks for watching.